In this video, I'm going to talk about the Flames extended argument passing mechanisms, and I have the Flames documentation up here. I have version 21 of the documentation up, and I'm in the developer's manuals and a manual we call the Flames Development Guide. And there's a section in there called Extended Argument Passing Mechanisms. That's what I have selected right now. And we have two extended argument passing mechanisms, records and mals. So before I talk about those different types of argument mechanisms, let me tell you why it is that we've defined these in Flames. They are extremely important. They're one of the bread and butter foundational aspects of Flames, the Flames architecture. And when I get finished explaining this, I think you'll understand why. We use these argument passing mechanisms when, in a lot of cases, but one particular case is when one model is interacting with another model. When Flames is interacting with your models, it's using a bunch of methods that are defined usually in the fEntity class, and those methods, those member functions, have a specified argument list. They're always the same. The methods all conform to that argument list. It's really pretty simple. It gets a lot more complicated when two different models are interacting with each other. And the reason it gets more complicated is because Flames has no way of knowing what particular data needs to be passed between the models when they're interacting with each other. These will be because Flames doesn't have any models in it. The models are always written by somebody and they're outside of Flames. It's not a real big deal if you were the only one doing model development and all the models that you ever wrote were going to be ones that you wrote. And so you write all the methods that you're going to use to allow models to call each other and pass in data and get data back out. And you pick what arguments you want them to have, and you set it up that way. And if it was just you and it was just your little set of models, it wouldn't be such a big deal. But in Flames, it's not the case. We have a framework that is independent of the models that get developed, and there's people all over the world that are developing models, and it's quite likely over the course of time that you're using Flames that you're going to want to use a model that was written by somebody else. In fact, that's probably going to happen pretty quickly. Flames comes with a bunch of models in the Flames store and the Flames repository. The starter models are a perfect example. It's very likely that in your first experiences with Flames that you're going to use those starter models. And when you write your first model of your own, you make a copy of it, create your own model, it's going to be likely that model is going to be interacting with some of the starter models. So you're not going to make copies of all the starter models. You're going to make a copy of just a particular model that you're interested in. So I'll give you an example. Let's say that you're going to write a new sensor model. And a lot of Flame sensor models use data processors to process track information, and they use antenna models to model the antenna gain of the sensor. For example, let's say it's a radar. So Flames has some sensor models. Flames has some data processor models. It has some antenna models. And you want to write a new sensor model. You've got a project coming up. You need a sensor model that does something different from what the Flames FQS radar model does. So you use the component copier. You make a copy of the FQS radar. You name it your own name, and then you want to go in and start enhancing it. Well, you may, and it's pretty likely, you may not want to actually write another data processor model, and you may not want to write your own antenna model. You might be fine with those models, and you don't want to have to copy those as well. So you'll write your own radar model, but you'll still keep using the Flames data processor model and the same antenna model. So there's a case where you write a model that's going to be interacting with the model that's written by somebody else. In all those cases where models are interacting with each other, Flames has also defined methods that should be used in almost every case for the models to interact with each other. Those are called the attribute methods. There are other places where models interact, but the attribute methods is a really common example. Attribute methods are ways that that one model can pass in new parameter values to a model or get values back out, or it can control the model. Well, the attribute methods are not for controlling, but control actually uses the extended argument passing mechanisms as well. So one model controls another model, like a cognition model controls a platform to fly the platform. In all those cases where models are interacting with each other, Flames has defined a set of methods, and we talk about them in the documentation. We're going to talk about them in our tutorials. And these are the methods that we say that you should use whenever you're interacting with another model. You have the option, when you write your own models, as I talked about earlier, of just writing your own methods and calling those directly and specifying the arguments. But we highly, strongly, emphatically say don't do that. Because if you put certain methods on your class, you now make it impossible for a class that somebody else wrote to be able to interact with your class. They may not have the source code to it. They may just have a DLL. They don't know what your mechanisms are. And it would be an absolute nightmare if everybody had to go figure out, well, what are your methods? And I got to recompile my code to work with your model. Models couldn't be swapped out. In Flames, even in the starter models, we can take a given radar model, for example, and we can put different antennas on it. Well, how is it that we can swap out and put different antennas? It's because we're using the methods defined by Flames to allow those models to interact with each other, and because they do that, they have a standard interface for the way that they interact. So we would call that the physical interface. The physical interface, the interface that allows models to call each other, is defined by Flames. So we define not only, again, the methods that Flames use to interact, we define the methods that models use to interact with each other. In order for us to define those methods, we cannot hard code the argument list. If we hard code the argument list, the method then becomes very restrictive in what it can do. We could define a variable argument list, but variable argument lists, if you've ever used them, a standard language like a C++ variable argument list, those are a real pain in the butt. And they also assume that the arguments are a certain data type and in a certain order. So they're not really very useful at all. We had to come up with a much more flexible and what we call an extended mechanism for passing data between functions. We call those the extended argument passing mechanisms. So there's the background, very important. With these extended argument passing mechanisms, you can use the Flames methods for interacting between models. So you use our methods, our member functions, but you can pass through with those methods any data that you want. So that's the purpose of these passing mechanisms. So the first one I'm going to talk about is records. So a record is just a data structure, very simple. You can pick any data structure that you want, and you can pass one data structure from one in an argument to another call, and you can and the other guy will get that data structure and use it. Now we're going to show you how that works. There's some little bit of extra work, but you have the flexibility to use any data structure that you want. And if a model already uses a particular data structure, well, you can get the include file, use that data structure, and pass that data structure in. The question is, how do you know what the data structure is? Well, the way that you know, so this is just an example of a data structure, and there's a limited number of types that you can put in a data structure if it's going to be a Flames record. Well, actually, technically, that's not true. You can put in any kind of data you want, but as I'll talk about later, there are some limitations on the type. The only thing you have to do to make a data structure a Flames record is define a unique ID for it. So in all the functions where records are passed in as arguments, you always pass in an address of a structure, but it's usually just a void star, because the formal argument declaration does not specifically identify the data structure. You can pass in the address of any data structure you want. But along with it, there's always a record ID, and it should be a unique number. So in Flames defined methods that take in records, they have a void star for the address of the structure and an ID that identifies the record. The ID has to be a unique number. So the way that we give you for defining unique numbers to make sure that nobody else in the world is using that same record ID is we give you this little macro right here that takes two arguments. The first argument should be your unique organization ID, which you can get from Turnitin. And then it's reserved for you and nobody else will have it. The second number is a number that you have to keep up with, that you have to make sure is unique for all the records that you define. This little macro puts the organization ID in the upper 16 bits and your unique ID in the lower 16 bits, so you get a unique integer value. Then what we recommend is you take that thing and you define a macro for that, and that'll be the macro that you pass in all your arguments whenever you're passing in an address to that particular structure. So the function that you call can look at that ID and it can make sure that it recognizes that record. Now, of course, the one who writes that function has to write his code so it does recognize the record. And we'll talk more about that in the interfaces in another topic on entity model interfaces. But this gives you a general purpose mechanism for passing in any type of structure as an argument to the Flames functions. And we'll talk in other tutorials about which functions use records as their arguments. The other standard argument passing mechanism is a MAL, which is an acronym for a model argument list. We use MALs a lot. We use records a lot in Flames. We use MALs a lot in Flames. Oh, let me go back to records for just a second. I forgot to mention something. Defining a record ID is the minimum thing you need to do for a record to make it a Flames record so you can pass it into functions. But sometimes records need to be registered with Flames. And when you do that, you take an instance of the record, you give it your unique ID, and then you say how many fields are in it, and then you describe each field. And Flames will keep a record of this in the record manager. I'm not going to explain right now the instances where it's necessary to register the record with Flames. That'll be covered in cases where the context warrants it, but just wanted to mention that to you. Sometimes in order to properly define a record, you have to register it. So now back to model argument lists. Model argument lists are used a lot in Flames. They are just one of the most wonderful things, and they enable us to create this model independent framework. We talked already about the fact that you can't have, in order to have real flexible methods, you can't have fixed defined arguments. So this is a way that gives us a way of not passing in some fixed structure, but passing in a basically a variable length argument list. But the formal argument to the function is just a MAL. The way you create a MAL is you include this include file for MAL, and that's usually included already in one of the other files that you include. Like if you're an equipment model, you include a base equipment model include file, and that'll have MAL in it. So you declare a local variable, a MAL object, and then you create it. And after you get done, you got to make sure that somewhere along the line, the MAL eventually gets destroyed. And the MAL is, whenever you call one of these Flames defined functions that takes in a MAL, you always need to check the documentation on that function to make sure that you know what that function does with the MAL. Some of those functions take over ownership of the MAL, and they will destroy the MAL when it's appropriate. Other functions don't destroy the MAL, and they'll give it back. They'll leave it alone, and you'll be responsible for destroying it yourself. As we talk about the functions where MALs are used, the tutorial will tell you when you need to destroy it and when you don't. Most of the time, you don't need to destroy it, but there are a few cases where you do. So if you're not sure, check the documentation. So you create the MAL, and then you add variables to it. So a MAL is very simple. It's a list of arguments, but each argument has a name, and it has a data type, and it has a value. So one of the things that's nice about a MAL is the called function, the function that receives a MAL as an input, can go and get the values out of the MAL. If it knows what the values are, they're supposed to be there, it can just say, I want the value of a position variable that's named this, and it'll just give you the value right back. If it doesn't know what the arguments are, it can loop over the arguments, and it can see what's the name, what's the data type, and then if I recognize it, I can get the value out and I can do something with it. So they're extremely flexible, and that's why we use them so many places in Flames. So the typical flow is you create the mal, then you add one argument to it at a time, and there's a whole series of add mal routines for adding different Flames data types to it. So these is all of them right here listed in this topic. There's a bunch of them, and each one of these is described in the Flames documentation. Well, actually, these are not. I don't know if they're in there or not. So you add one argument at a time, and then you pass that into the calling function. And so you take that argument right there and you pass it in. Sometimes you'll just put one argument in, you pass it in. Sometimes you'll put multiple arguments in and you'll pass it in. And again, most of the time, the function that you call will destroy the mal for you. You won't have to do anything with it. In some cases, you'll be responsible for destroying it yourself. So we'll talk about those cases when we talk about the different kinds of methods. The function that receives the mal as an argument has a number of ways to get the values back out. In fact, there's a corresponding get routine for all of these add routines, and you can also loop over the mals to the mal and get the arguments out individually. So that's all that I want to say for the moment about the extended argument passing mechanisms. We will talk more about records and mals when we're talking about the functions that actually use them. Thank you for listening, and thank you for choosing Flames.